Dr. Butler, you're recognized for 5 minutes. Thank you.
Good morning, Chairman Latta, Ranking Member Schakowsky, and members of the subcommittee. Thank you for the opportunity to testify today. My name is Gary Butler, and I am the founder and CEO of Camgian Microsystems Corporation, a developer of advanced sensing and analytical processing technologies. Camgian, a Starkville, Mississippi-based high-tech company, has been recognized by leading technology analysts such as Gartner for our product innovation in the Internet of Things sector. While much of the attention in IoT has been focused around consumer applications, our efforts are addressing the commercial market. Sometimes described as the industrial Internet of Things, this segment of the IoT space represents a new form of intelligent systems that are optimizing the dynamic of humans, data, and machines to drive revolutionary gains in productivity and efficiency. From maximizing asset utilization to improving safety, industrial IoT technologies stand to transform business and drive a new wave of global economic expansion. To address this opportunity, we developed Egburt, an award-winning IoT software platform built on an edge computing model. Egburt performs advanced multi-sensor data processing at the network's edge to enable efficient and scalable IoT operations with economical utilization of communications resources. In partnership with our clients, we are developing industrial IoT applications built on Egburt in areas related to condition-based monitoring and maintenance of remote high-value assets and equipment. Based on our experiences in developing and deploying such systems, I would like to offer the subcommittee my perspective on the state of industrial IoT and its future. At Camgian, we see IoT as a critical technology trend that doesn't merely connect the physical world, but powers it using advanced computing. That is to say, IoT extends the reach of today's software and data processing technologies far beyond traditional internet boundaries and into the physical world around us. This is enabled through a system architectural model where industrial assets are imbued with sensing, processing, software, and communications technologies. The result is the generation of critical insights into the operation and maintenance of industrial systems that were previously unavailable. Today, such insights are driving better and faster decisions and delivering enormous economic business and economic advantages to companies and organizations worldwide. A case study includes our work in condition-based monitoring, where we are partnered with clients responsible for managing the reliable operations of remote industrial assets. Examples include large civil infrastructure systems such as locks and dams, and power systems for marine operations such as diesel engines and generators. In these cases, downtime due to unscheduled maintenance can represent millions of dollars of economic loss. To address this problem, we are leveraging Egburt in the development of new applications that will provide operations and maintenance personnel the ability to remotely and efficiently monitor the condition of large numbers of industrial assets across their enterprise. Specifically, this includes the remote collection and analytical processing of large volumes of asset sensor data to identify failures before they happen and drive radical improvements in operational reliability and safety. The potential value of eliminating unscheduled downtime across the industrial sector is enormous, but represents only one example of the economic power of this technology trend. Similar IoT-enabled gains in productivity, cost reductions, and worker safety are emerging in other markets and are now driving the technology's widespread adoption throughout our society in areas such as transportation, manufacturing, oil and gas, healthcare, power distribution, and agriculture, to name a few. Management consultant Accenture estimates that industrial IoT technologies could add $14.2 trillion to the global economy by 2030, including $7.1 trillion to the United States. Looking ahead, fueling this growth will be new innovations in advanced sensor and analytical processing technologies. With billions of industrial sensors deployed today and growing, exploiting the untapped value of the massive data sets generated from these devices will be the next big leap in IoT's technology evolution. With Egburt, we are tackling this big data challenge through a confluence of innovations in real-time signal processing, data analytics, and machine learning with the aim of transforming today's human-centric IoT models into semi- and fully autonomous intelligent systems. This will include automating the data-to-decision continuum a tipping point in IoT's evolution that will spark a wave of automation, reinventing industrial processes, and transforming the future workforce. Thank you, and I look forward to your question.
Dr. Butler, welcome. We're glad to have you here. And what year did you start Camgian?
2006.
Okay, 2006, and we're now 2017. Did you envision the progress that you would have made to this point when you talk about where we are today with IoT?
I didn't. I think we're making great strides in the United States in advancing this technology. I think the opportunity for the United States is significant, both domestically in terms of operational savings and productivity, but also as a business that we can propagate to the rest of the world.
Let's talk a minute about what is an important issue and an ongoing almost crisis, and that's our aging infrastructure that we have in this country. I know the president was in, I believe, Ohio recently, and your company, Camgian, along with Egburt, your technology that you have, tell us a little bit more about how that's impacting, particularly at the Markland Lock and Dam on the Ohio River, and what you see is this technology to help us with that aging infrastructure.
Sure. Our software has been built to provide enterprise remote monitoring applications. So, for example, it's very flexible in terms of integrating advanced industrial sensors and then also integrating the sensor processing and analytics associated with that data. So we can build very scalable products that can extend out to this type of infrastructure. Now, when considering the aging infrastructure problem, one of the problems that we have in the United States today, a lot of these large critical systems were built more than 50 years ago with a 50-year lifespan. So what we're seeing now is that the unscheduled maintenance of these systems is rapidly increasing. So in addition to new innovations in terms of repairs and refurbishment, concrete and steel, it's our thesis that data can bring a lot to that market by making these systems intelligent, by imbuing these systems with sensors and communications and analytics technologies can provide both engineers and operations personnel real-time valuable insights into the structural health and operational conditions of these systems over time. And so they can use that information to make better decisions about how to address some of these problems before they become failures. A system like the Markland Lock and Dam, for example, if that system goes down, it's millions of dollars of economic impact to the local economy per day. So it's very important that these systems maintain significant uptime in their operations.
And these sensors and this information that's gathered real time, it allows you to know when there's perhaps a crisis, perhaps a problem that needs immediate concern, and helps them stay on a better maintenance schedule, I assume.
That is correct.
Okay, that's great.
That is correct.
You know, you also stated that the industrial Internet of Things applications certainly are driving some amazing revolutionary gains in businesses. So what you're doing there is through the Army Corps, U.S. Army Corps of Engineers there at Markland. But talk about what you think we're going to see or what we should look for is how this really benefits businesses on what you're doing.
Sure. I think that same model, when it comes to improving downtime and reducing failures in mechanical systems, it applies and extrapolates across a number of industrial markets today. That includes areas like manufacturing. It also includes areas like agriculture. It includes areas like transportation, healthcare, energy, for example. Any of these industries that rely on equipment to drive their business model, these types of efficiency gains are enormous in terms of significantly reducing any downtime in those systems, and then also the aspect of security and safety with the failure of these types of systems. So the type of work that we're doing with the Corps of Engineers today, I think, also applies across the industrial industry, or industrial market and sector in general, and not only applies obviously to domestic problems that we're addressing here in the United States, but also around the globe.
So when we're looking at this, particularly how we make sure that Congress doesn't get in the way, do you have any thoughts as to what we can do to help as we develop the industrial IoT?
Yeah, good question.
This is your chance to give us advice.
Sure. I think, you know, Dr. Bachman said a moment ago that this is the most significant technology trend of the 21st century, and I agree with him on that matter. This could be an enormous job creator for the United States in the sense that the value that can be extracted from industrial IoT technologies is enormous across industries, as we've heard. So as it relates to what the federal government can do, I think really three things. Number one is to lay out a national strategy for IoT that's focused on becoming the leader in the world. Number two, serving as a catalyst to start this market. That has been done previously with the internet and the DoD and the ARPANET. I think we need to do the same thing in the industrial IoT, and I think smart infrastructure is a great place to start. Because if we can build and deploy systems in that market, that will extrapolate to other markets and help us grow, again, both domestically and internationally. And if you think about job creation, if I were to, as a high-tech company executive, if I think about scaling my business, the jobs that would create are product engineering jobs, jobs for electrical engineers, jobs for mechanical engineers, jobs for industrial engineers, computer scientists, service jobs. So there are lots of jobs that can be created here, and we can service the world with these types of technologies if we decide to take the lead in the market.
Dr. Butler, can you please explain how connected devices and internet connectivity capability have affected your business?
It certainly has put us now in a position to scale our business. I think it's a tremendous opportunity, again, across multiple markets. So it allows us to scale in a variety of different industries beyond some core industries that we are focused on today. I think if you look at the makeup of the workforce that we have in our company today, again, as I mentioned to Congressman Harper earlier, we have product developers, both electrical engineers, mechanical engineers, industrial engineers, but we also have software developers. We also have service, people that support the service side of our business, and sales, marketing, and of course, finance. And I think that over time, as we scale our business, we will scale in all facets of that business. And so I think in terms of creating more job opportunities in the United States, if we are the leader in this industry, and we are the provider of these technologies and services to the global economy, we'll see job creation across that entire spectrum of our workforce.
And have you seen increases in employment in recent times?
Yes, and we are hiring now. We plan to hire a number of new engineers as it relates to percentage of our total employee base by the end of this year. So we are growing on the back of the IoT industry at this point.
And regarding employment of engineers, is there a flow from our graduate schools regarding engineers in this country?
Yes, I think for us it's a combination of both. We hire new college graduates and we also hire more experienced engineers as well. A lot of times we look to hire experienced engineers to take on new project management roles and leadership roles in the organization, and then we bring in new college graduates to work with those more experienced engineers as part of our product development program. So I think it's really a combination of both.
Dr. Butler, is there anything we can do as policymakers to promote the growth of industrial IoT? For Dr. Butler.
Yeah, I think there are a few things. I think number one, continue to work with organizations like the IIC and the OIC, the consortium that are today looking at how to grow the industrial IoT space. I think, as I mentioned earlier today, I think adoption would be great. I think the opportunity for adoption within the federal space today is significant. And I think if we look back historically on how the internet came to pass in its growth, the federal government was instrumental in that in terms of the development of the ARPANET and the NSF funding that went along with that to serve as a catalyst. So I think adoption in certain areas. And then I also think funding research and development, some of the key areas to provide competitive advantage, and I think a light regulatory touch to promote innovation.